Harsha of BCA department from Milagres College, Mangalore. Today in this session, we are going to discuss a process concept in our operating system. Before getting into the point process concept, let's learn some points in our operating system. So what is operating system? That is a computer program that manages all peripheral devices of the system such as mouse, keyboard, printer and scanner. So let's see what our process. A process can be thought of a program in execution. That is nothing but a program under execution is called as a process. So what is program? Program is a set of instructions that needs to be executed. When you run the program and that is under execution, that is called a process. Now these processes that will need certain resources such as CPU time, memory, IO devices in order to complete their task. So now these resources are allocated to the process either when it is created or while it is executing. The process is a unit of work in a system, in most of the system, that such system that consists of collections of the processes. So we know what is a process, that is a program under execution. The program under execution is called as a process, and the running program that may request access to the IO devices, they will not have the direct access to these devices. In such cases, operating system give access to use those resources. So there are different process state called new, running, waiting, ready and terminated. As a process executes, that keeps changing this state. So each process that may be of the following state. The first one is the new state. The process is being executed. The process just being executed or created, that is in a state, new state. So the second one is the running. Instructions are being executed. When the instructions of the process are executed, that changes its states from new to the running. That means program is executing. Next we have a waiting state. The process is waiting for some event to occur. That means when the running process that requests access to use hardware resources such as mouse, keyboard, scanner, printer. So in such cases, that process that goes to the waiting state. From the running state, it will go to the waiting state. The fourth one is a ready state. The process is waiting to be assigned to a processor. That means all the processes in the main memory that are ready to execute are considered as a ready state. When the process is ready for its execution by the CPU, in such cases the state changes to the ready state. The last state is a terminated state. The process has finished its execution. That means when the process finishes its execution, it executes all the instructions in the program. In such cases that are termed as a terminated state. So now this is a graphical representation of a process state. There is a different process state. We have running, ready, waiting, new and terminated. First it will be in a new state. Now once it is ready for its execution, that changes its states to the ready state. After which it will run the program by the CPU. CPU will run the processors, and in such cases it changes its state from ready to the running. So in such cases, after some time, so when it is executing, it may request access for resources such as mouse, keyboard and printer. So in such cases, that changes its states from running to the waiting. And the last one we have a terminated. When the process executes all of its programs, that will be termed as a terminated state. Next we have a process scheduling concept. The main objective of multi-programming is to have some process running all the time so that the CPU utilization is done in an efficient manner. Also, the objective of time-sharing system is to switch the CPU among the processors so that frequently the user can interact with each program while it is running. Now, in order to meet these two objectives, the process schedulers that selects the available processes from the main memory, that is for program execution on the core. So process scheduling is selecting the process from the main memory by the CPU for its execution. There are two things we need to learn while learning a process scheduling. Scheduling queues and the schedulers. So what is a scheduling queue? So that is a common representation of a process scheduling queue in a queue diagram, which is called as a scheduling queue diagram, in which each rectangular box that represents a queue. There are total two queues, ready queue and the IO queue. Now, what is ready queue? A process is initially put in the ready queue when it is ready for its execution. It waits in the ready queue until it is selected for execution by the CPU. That means all the processes that resides in a main memory that is ready for its execution will be taken into the ready queue. Now, once the process is assigned to the CPU and it is executing, some of the events could occur, that is, a process could issue input-output request in the then that processes will be taken into the IO queue or also called as a device queue. A process could create a new sub-process. In such cases also, they have to wait for its termination. In such cases also, those processes will be taken into the device queue. And the last, the process could be removed forcibly from the CPU as a result of an interrupt put back into the ready queue. When the process that is running by the CPU has stopped forcibly, in such cases also, they have to go from to the IO queue. That means they have to wait in a ready queue. Now, this is a graphical representation of a scheduling queue, or it is also called a queuing diagram of a scheduling queue. So, first, the ready queue. The CPU selects all the processes that ready for its execution from the ready queue. So, these are the some events that occurs during the execution of the process. They may request input-output request in order to utilize resources such as input and output devices, keyboard, mouse, printer. So in such cases, they will be taken into the input-output queue. After they are done with the input-output operations, they will be taken back to the ready queue. And we have some more events that could occur while executing the process, that is time slice expire, fork a child, or wait for an interrupt. So after all performing their own operations, they are back to the ready queue so that they can be executed by the CPU in a later. So next we have a schedulers. So what are schedulers? That are a software which selects available program to be assigned to the CPU. So the schedulers are nothing but we are selecting the processes which resides in a main memory which are ready for its execution. We are allocating those processes to the CPU for its execution. So there are two types of schedulers, job schedulers, CPU schedulers. So what is a job scheduler? Job scheduler is also called as a long-term scheduler that selects the job from the job pool. That means all the processes that resides in the system, either it is in a secondary storage or the main storage, all these are selected and put it in a main memory for its execution. That is called job scheduler. It selects all the process from the job pool and loads into the main memory. Why it loads to the main memory? Because the processes which are resides in a main memory can be executed by the CPU. CPU only looks for the main memory where there is a process which are ready for its execution. So, if more processes are submitted, then that can be executed immediately. Such processes in a secondary memory. It runs infrequently and can take time to select the next process. So, second type of schedulers is a short-term scheduler, which is also known as a CPU scheduler. CPU schedulers that selects a job from the memory and assigns a CPU to it. That means now job scheduler has loaded all the processes into the main memory. Now CPU scheduler that selects the job or the processes from the main memory and it allocates the CPU for its execution. So now it must select a new process for CPU frequently. And we have a medium term scheduler that selects a process in a ready queue and it reintroduced into the main memory. Now, a process can be described as either. So, we may have I/O bounded processors that spends more time doing I/O than the computation. There are two types of processes, I/O bound process or CPU bound process. So, what are I/O bound process? I/O bound processes are collection of process that spends more time doing the input and output operations than the computations. Whereas CPU bound process are the process that spends more time doing the computations than the input output operations. So an efficient scheduling system that will select the good mixture of the CPU bound processes as well as the IO bound processes. So that is why, because if the scheduler selects more IO bound processes, then IO queue will be full and ready queue will be empty. If the scheduler selects more CPU processes, then ready queue will be full and IO will be empty. That is why there must be a good mixture of CPU bound process and the IO bound processes. Now this is a graphical representation of schedulers wherein from the ready queue the CPU scheduler selects the process in order to assign the CPU for its executions. If there is in between there is an event such as IO waiting operations, in such cases those processes that enters device queue, once it is done with its operations, that is IO operations, they will be taken back to the ready queue. Thank you.